Hello, good morning, students. Today we're gonna talk about the ordinary differential equations. So let's really quickly try to understand what are the differential equations. So let's say we have y is equals to f of x. So if we add their derivative, the first derivative dy by dx, the second derivative dy square over dx, or the third derivative d cube dx in these equations. These are all the derivatives. So an equation that includes the derivatives of a and independent with respect to dependent one, x as an independent, y as a dependent function, we call it the differential equation. So the examples are dy by dx is plus x over y is equals to 0. All right, or you can say that another example is equals to dy is equals to x plus sine x dx. All right, so these are the different examples. So let's go and check that what is the order of a differential equation. For this one, to understand, the order of the differential equation is the order of the highest order derivative in a differential equation is called the order of differential equation. So to understand it, let's try to understand it with the help of one example. Let's say we have d over dy over dx plus dy over dx squared is equals to e power x. All right. So in that case, you will say that the order is 3. Why? Because the highest derivative is 3. Similarly, if you take another example in which dy over dx plus y is equals to e power 2x. In that case, you will not say that the order is 3. The order is still 1. So we can say that order is 1. Okay, so it will come from here. Similarly, the other thing is degree. Degree of differential equations. What is the degree of differential equation? The degree of differential equation is the degree of differential equation is the degree of the highest derivative is called the degree of the differential equation. So for example, let's say we have an example d over dx cube plus dy by dx squared is equals to e power x. So in that case, degree will be in that case, the degree will be equals to uh, the highest derivative is 3, so its power is 1, so degree is 1. So you will not say that the degree is equals to 2 in that case. All right. So in another example, dy by dx raised power 3 plus d over dx, maybe y squared plus 1 is equals to e power 2x. So in that case, degree is equals to the degree in that case will be equals to the highest is 1 in hand 1 here. So we will go with this one, right? So degree will be 3 in that case. All right. So let's just try to take other examples. Let's say we have an equation d squared, the second derivative sine dy by dx is equals to 0. When there is a trigonometric function, in that case you will say that the degree don't exist in that case. So order, in that case the order is equals to 2. Order is equals to 2 and degree so when there is a sine, cos, tan, log, maybe exponent function, so in that case degree doesn't exist. All right, so let's try to look another example. Let's say we have example 1 in which we say that we have dy by dx is equals to x plus sine x. So we will check 1 and 1. So both order and the degree is 1, but once it involves the sign, so in that case we will say that the degree doesn't exist in that case, but the order is gonna be 1. So our next thing is linear differential equations. What are linear differential equations? Linear differential equations will be the equation if the dependent variable and every derivative occur in the first degree. So the highest power should be 1 in here. So in that case, we call it the linear differential equations. And the second thing is that the first condition is every dependent variable and every derivative occur in first order. And second condition is that no product term of derivative or variables. All right. So let's take a look for let's say we have equation y is equals to x dy by dx plus a 1 plus dy by dx is power 2. So in that case, what is the order? So 1. So order is 1 and the degree is 2 in that case. And I think, yeah. So I hope that you understand what is the uh, order, what is the degree, what is the linear differential equation, or like that. So there are various methods to solve these equations. So the solution for the solution, we have various methods. So we have number one, Picard method. Number two, we have Taylor method. Then we have Euler's method. Then we have Range method. All right. So later in the video, I will tell you how to solve. We will start with the Picard method. Moreover, in this type of question, the important thing is that the initial conditions. So for example, always keep in mind that the ordinary differential equation, they don't have only one solution. There are series of solutions. All right. So for example, let's say you are on a ground and there's a person that is throwing the ball maybe in the air. So what will happen? It will go up, and maybe somewhere here, and then it will come back and hit the ground. All right. So if I ask you that from his hand from to the top edge, what is the height? So this height, it is dependent on the initial condition. If he throw the ball from here, or what position he is throwing the ball in the air. That is the important thing. So in this type of questions, you will see that there will always be initial conditions. It is the same like if I ask someone that when you gonna come my home. So based on his condition, the current location, he can tell me that I can come 30 minutes or 40 minutes or an hour or in 5 minutes like that. So same is the case with this ordinary differential equation. All right. So it is dependent. What is the initial condition? Let's say if I throw from this position with the same force, maybe it will go attain more height. If I throw from here with the same, it will attain less height. So that is the thing that you should keep in your mind, that the initial condition, they are really important in this by when we solve the ordinary differential equations. So in my next video, I'm gonna tell you how to solve ordinary differential equation using Picard method.